Okay, so this is the review sheet, the answers for the review number 3. All right, so let's take a look at number 1. So number 1 says, for each polynomial function, find the zeros, sketch a graph of the function, and describe the end behavior. And again, no calculator, remember. Okay, so let me write down the first one. Okay, so this polynomial is already in factored form. So the first thing I'm going to do is I'm going to find the zeros. So I have x equals 0. The exponent of my factor is even. So that is even and will be tangent at 0. The next one is x is equal to 9. My exponent for my factor is also even here, so it's tangent. The next one is x is equal to negative 4. So the exponent for my factor is odd, because there's really a 1 there. So that means it crosses. And x is equal to 2 for the last one, and it's odd also because my exponent is odd. So that means it crosses. All right, so let's take a look at what the graph would look like. So I need 0 on here, positive 9, negative 4, and positive 2. Okay, so I need the degree of the polynomial, so count up the exponents. So the degree is, let's see, we have 2, 4, 5, 6, so it's a degree of 6. So it's either up, up, down, down. So the leading coefficient is positive 1, so that means it's up, up. Right, so it's up, up like this. So it's going to cross at negative 4. So it's going to come down, cross at negative 4, bounce or be tangent at 0, cross at 2, come down and be tangent at 9, so it'll look like this. All right, so now what I need is my end behavior. So as x goes to negative infinity, so as x goes to the left, my y goes to positive infinity. So f of x goes to positive infinity. As x goes to infinity, as x goes to the right, my end behavior goes up to the right also. So f of x goes to infinity. Okay, so let's take a look at b. Okay, so for b, it is not in factored form, so I have to get it in factor form. So for the first parentheses here, there's a GCF and it's negative x times x squared minus 1. And then I can factor that again, it's dots, so it's x times x plus 1 times x minus 1. And then this here factors and becomes x minus 6 and x plus 1. So we have here f of x is equal to negative x. We have actually 2x plus 1, so it's x plus 1 squared, x minus 1, and x minus 6. All right, so let's see what we have here. Let's find our zeros. All right, so for the first one here, so we have x is equal to 0. The exponent is odd, so that means it will cross. My exponent here for x is equal to negative 1 is even, so that's tangent. X is equal to 1 here. The exponent is a 1, so that's odd. It will cross. And x is equal to 6. The exponent is a 1. It's odd, and it will cross. Okay, so let's see. Our graph will look like. So I have a 0 at 0, 1, and 6, and then also at negative 1. Okay, so the degree, count up the exponents, so I have 3 here, and 2 here, so the degree is 5. And my leading coefficient will be in negative 1, so it will look like this. So my graph will come down, be tangent at negative 1, so bounce back up, cross, cross, cross. So it'll look like that. Now I need my end behavior. So as x goes to negative infinity, f of x goes to, so as x goes to the left, my y goes up. So that goes to infinity. As x goes to infinity, so as x goes to right, my y's go to negative infinity. Okay, so let's take a look at number 2. Okay, so number 2 says, what are the most zeros and extrema a polynomial of function n degree n can have? So if the degree is 5, it can have 5 zeros and 5 minus 1 extrema. So that would be 4. So we'll have n zeros, and I'll have n minus 1 extrema. So let's say I have this, say I have x to the 5th plus 6x squared plus 4x plus 1. So my degree is 5, right? So it will have at most 5 zeros, and it'll have 5 minus 1, so it'll have 4 extrema. Okay, so let's take a look at the next one. All right, so it says if f of x is equal to x to the third and g of x is equal to x minus 2 to the third minus 2, state your transformation from f to g and then graph both. All right, so f of x is equal to x to the third. So if we graph it, so use your table of values. Right, so here's my table of values. This is for x to the third power. So it's negative 2, negative 8, negative 1, 0, 0, 1, 1, and 2, 8. So plot the points, and so we have, just going to get some lines here. Okay, so I have negative 2, 8. Negative 2, negative 8, sorry. Negative 1, 0, 0, 1, 1, and then 2, 8. So it looks like that. All right, so now this is mapping to g of x, which is x minus 2 cubed minus 2. So what's happening to the graph? I'm minusing 2 from x. That means we're going to the right 2. And then minusing 2 from y. That means we're going down 2. All right, so I'm going to each one of these points. I'm going to go to the right 2, down 2. So to the right 2, down 2. To the right 2, down 2. To the right 2, down 2. So it'll look like this. Okay, so let's take a look at number 4. Okay, so number 4 is to use the leading coefficient test and describe the end behavior. Okay, so let's take a look at number 1. So I have a degree of 3. And the leading coefficient is positive 4. So since my degree is 3 and the leading coefficient is negative 4, sorry, not positive 4, it'll look like this. So now I want my end behavior. So as x goes to negative infinity, f of x goes to infinity. And as x goes to infinity, f of x goes to negative infinity. Okay, so let's take a look at b. So the degree for b, the degree is 4, and the leading coefficient is positive 1. So it'll be up, up. Okay, so as x goes to negative infinity, f of x goes to infinity. As x goes to infinity, f of x goes to infinity. Okay, let's take a look at C. So C is, the degree is 5, and the leading coefficient is positive 3. So it'll be like this. So as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x goes to infinity. And now let's take a look at D. So D is, the degree is 2, and the leading coefficient is negative 5. So it'll be down, down. So as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x goes to negative infinity also. Okay, let's take a look at number 5, which is the difference quotient. So here is the difference quotient. F of x plus h minus f of x all over h. So remember, that's the formula. You're just going to follow the formula. This is the function that we're using. We're using f of x equals 7x minus 8. So we're going to start with this. F of x plus h. Remember, this is my input, so I'm going to input x plus h into my x here. So it's going to be 7 times x plus h, because that's my input, minus the 8. Right, so I input it into that. Now I'm going to minus my f of x. My f of x is 7x minus 8. And then put it all over h. And now simplify. So distribute the 7. So we have 7x plus 7h minus 8. Distribute the negative. So we get minus 7x plus 8 all over h. Now simplify the numerator. So 7x minus 7x is 0. Negative 8 plus 8 is 0. So I'm left with 7h over h, which is equal to 7. All right, let's take a look at B. So let me write the difference quotient again. So we have f of x plus h minus f of x all over h. So the function now is going to be f of x equals 3x squared minus 2x plus 1. All right, so remember, we're going to start with this. This is my input. I'm going to input that into all my x's first. Starting with this, input h of x plus h. So it's 3 times x plus h squared minus 2 times x plus h plus 1 minus, so now we're going to minus the function, minus here, minus f of x, which is 3x squared minus 2x plus 1 all over h. All right, so let's start with this here. So it's 3 times, so now you should at this point know what x plus h squared is. That's x squared plus 2xh plus h squared. All right, now I'm going to distribute the 3. So we get 3x squared plus 6xh plus 3h squared. Now I'm going to distribute the negative 2, so it's minus 2x minus 2h plus 1. Now distribute the negative to the f of x, so it's minus 3x squared plus 2x minus 1 all over h. Sorry, it kind of went on a diagonal there. All right, so now we're going to clean up the numerator. So we have 3x squared minus 3x squared, so that's 0. We have negative 2x, positive 2x, 0. Positive 1, negative 1, 0. So what are we left with? We're left with positive 6xh positive 3h squared minus 2h, all over h. All right, now you're going to reduce. Remember, we're going to reduce h with all three terms. So we have 6xh divided by h is 6x, because the h's will reduce. 3h squared divided by h would be positive 3h, because the h squared and the h reduce. And then minus 2h divided by h would be minus 2. Okay, so let's take a look at number 6. Six is the long division, okay? All right, so we have my divisor is x minus 4. My dividend is 5x squared minus 17x minus 12. And always remember, make sure you have a term representing, make sure you have a number representing every term in a descending order. Okay, so x times what gives me 5x squared is 5x. Multiply down, I get 5x squared minus 20x. And now we subtract. So this becomes plus, minus, plus in here. So the 5x squared cancels, and I'm left with 3x, and then bring down the minus 12. X times what gives me 3x? That's positive 3. Multiply down, I get 3x minus 12. Now subtract. This becomes plus, minus, plus. Cancels, cancels. The remainder is 0. So my answer is 5x plus 3. And remember, when the remainder is 0, that means that these are factors. Okay, let's try the next one. All right, so my divisor is x minus 2. And my dividend is x to the 4th plus 5x cubed plus 6x squared minus x minus 2. All right, so x times what gives me x to the 4th? That is x to the 3rd. Multiply down. I get negative 2x to the 3rd and x to the 4th. So now subtract them, so it becomes plus, minus, plus. X to the 4th cancels, and I'm left with 7x cubed, and then bring down the next number, which is plus 6x squared. X times what is 7x cubed? That would be 7x squared. Multiply down, I get negative 14x squared, and positive 7x cubed. Okay, subtract, so this becomes plus. Becomes plus, minus, plus. So the 7x to the 3rd cancels. And then I have 6x squared plus 14x squared is 20x squared. Bring down the minus x. And then we have x times what is 20x squared? That is 20x. Multiply down. And we get negative 40x plus 20x squared. So we subtract and we get plus, minus in here, plus. So 20x squared and 20x squared, they cancel. So I have negative x plus 40x is 39x. Bring down the negative 2. And then we have x times 39 gives me 39x. So that would be negative 78 and 39x. Minus, this becomes plus, minus, plus, cancels, and I get 76 is my remainder. So my final answer is x to the 3rd plus 7x squared plus 20x plus 39. Now my remainder, which is positive 76, over my divisor, which is x minus 2. All right, let's take a look at 7. Okay, so 7 is to take these and put it in a vertex form. Okay, so let's just recall what vertex form is. So vertex form is f of x equal to a times x minus h squared plus k. And remember, hk is the vertex, and the axis of symmetry is x equals h. All right, so let's take a look at the first one. So it's f of x equals negative 4x squared plus 24x minus 41. All right, so we have to have a leading coefficient of positive 1, so I have to divide everything by negative 4. So I have f of x over negative 4 equals x squared minus 6x plus 41 over 4. So now move the constant over. So minus 41 over 4 from both sides. So f of x over negative 4 minus 41 over 4 equals x squared minus 6x. Do half of negative 6 is negative 3. Squared is 9. So we have f of x over negative 4 minus 41 over 4 plus 9 equals x squared minus 6x plus 9. Okay, so now let's add this here. So I have f of x over negative 4, and negative 41 plus 9 is negative 5/4 equals factor the right side, x minus 3 squared. Add the 5/4 back over. So we have f of x over negative 4 equals x minus 3 squared. Add the 5/4. Now you want to get rid of the negative 4 that's in the denominator, so multiply both sides by negative 4. All right, so the negative 4 is reduced to 1, so I'm just left with f of x equals. Make sure you get both of these here. So it's negative 4 times x minus 3 squared minus 5. All right, so then my vertex is 3, negative 5. Oh, I have an extra parentheses. I don't need that. So my vertex is 3, negative 5, and my axis of symmetry is x equals 3, and that has to be x equals. All right, so let's try the next one. All right, so I have g of x is equal to 1/2 x squared plus 8x minus 1. So I want to get rid of the fraction, so multiply everything by 2. So I get 2g of x equals x squared plus 16x minus 2. All right, now move the 2 over, so add 2 to both sides. So it's 2g of x plus 2 equals x squared plus 16x. So it's half of 16, which is 8 squared, 64. 2g of x plus 2 plus 64 equals x squared plus 16x plus 64. All right, so on the left side, I get 2g of x plus 66 equals x plus 8 squared. Minus the 66 over, so it's 2g of x equals x plus 8 squared minus 66. Now you have to get rid of the 2 here, so divide everything by 2. So I get g of x equals, remember there's really a 1 here, so it's 1/2 x plus 8 squared minus 33. Vertex, negative 8, negative 33. Remember, it's only the h that changes sign. And my axis of symmetry is x is equal to negative 8. Okay, so number 8 is given the polynomials, you have to perform the indicated operation. So we're adding f of x and g of x, subtracting g of x minus f of x, and then multiplying f and h together. Okay, so 8a, so it's going to be use parentheses because we have polynomials, so it's 3x squared minus x plus 3, Add that to x squared plus 5x minus 7. Since we're adding, you just combine like terms. So it's 4x squared, right? Add the squares. Negative x plus 5x is positive 4x. And then 3 minus 7 would be negative 4. All right, the next one. Make sure you put the right polynomial first because it's g minus h. So it's x squared plus 5x minus 7. Subtract 3x squared minus x plus 3. So you want to make sure you distribute the negative. So I get negative 3x squared plus x minus 3. Combine like terms. So I have x squared minus 3x squared is negative 2x squared. 5x plus x is 6x. Negative 7 minus 3 is negative 10. And then the last one we want to multiply. So we are multiplying 3x squared minus x plus 3, multiplying that by 2x minus 1. So I have negative 1 times 3 is negative 3. Negative 1 times negative x is positive x. Negative 1 times 3x squared is negative 3x squared. 2x times 3 is positive 6x. 2x times negative 1x is negative 2x squared. And 2x times 3x squared is 6x to the third. Add them down. When we add them down, we get 6x to the third. That's minus 5x squared plus 7x. And then I have minus 3. Okay, so let's look at 9. That's the synthetic division. All right, so I have my factor is x minus 1, so I want my 0, right? X equals 0. Okay, so I set this up. I put 1 on the outside. I need all my coefficients, which are going to be 2, 6, negative 14, 9. And remember, if you're missing a term, put in a 0. First, I bring down the first number, which is 2. Actually, let me write the polynomial first, because we're going to need that in the end. So it's an x to the third. Okay, so this was 2x to the third plus 6x squared minus 14x plus 9. Okay, so I bring down the 2. Now I multiply 1 times 2 is 2. 6 plus 2 is 8. 1 times 8 is 8. Negative 14 plus 8 is negative 6. Times negative 1 is negative 6. And I'm left with 3. So since my polynomial started off as an x to the third, it'll now be an x squared. So it's 2x squared plus 8x minus 6. This is my remainder, so it's plus 3 over my divisor, which is going to be x minus 1. Okay, so let's take a look at the next one. Okay, so we're starting off with 5x cubed plus 6x plus 8. So we're going to have to add in a 0 in there. And dividing by x plus 2. So my 0 is x equals negative 2. All right, so I put negative 2 on the outside. And I have 5. But now I need a 0x squared, 6 and 8. So start off by bringing down the 5. So then multiply by negative 2 and I get negative 10. So that's negative 10, positive 20. 26 times negative 2 is negative 52. 8 minus 52 is negative 44. I started off with an x to the third, so my 5 will now be an x squared. So it's 5x squared minus 10x plus 26 minus 44 over x plus 2. Okay, so that was 9. Now we're on 10. So this is, number 10 is to find where the zeros are using your table of values. So you're looking for the change, in the y values, the sign change. So plug in number 1 into your grapher. Go to table of values, you're looking for your sign change. So I see a 13 and then a -4. So there's a 0 in there. I see a -3 and then a 4. So that means there's a 0 here. And then 77. So at -2, -1, this is your interval. And 0, 1, 2, so here's your other interval. All right, so we write in the 1 unit interval, in the 1 unit interval, or I should say intervals, -2, -1, 0, 1, there exists a 0. All right, and now we have to do the other one. So plug in the next one, and this one's going to be a very long table of values. All right, so I have, okay, sorry about that, I had a little technical difficulties. All right, so I see 98 and then -7, so there's a 0 here. And then I have -22, -7, 2, so there's a 0 here. And then I have -7, so there's a 0 here. And then after -7, I have -22, -7, and then 98, so there's another 0. All right, so now I just need my x values. So -4, -3, that's my interval. And then I have -2, -1, 0, -2, -1 is 0. There's my interval. 1, 2, 3, 4. 1, 2, 3, and 4. So 0, 1 is an interval. And 3, 4. All right, so we write in the 1 unit interval. And now put down your intervals. -4, -3, -2, -1, 0, 1, 3, 4. There exists a 0. Okay, last one. Okay, so last one is to explain the multiplicity. So when your multiplicity is even, so an even multiplicity the graph will be tangent to the x-axis at that 0. Okay, when you have an odd multiplicity, the graph will cross the x-axis at that 0. Okay, so that's it, and happy studying, and have a good night.